It's the topic of the week, natural selection. Hey, Crocker. Thanks again for watching the screencast. Let's take a look at the topic of the week, natural selection. Remember, this is what Darwin said was the mechanism of evolution. Now, he didn't know about genetics. That genetics was the slam dunk that basically confirmed all this stuff because it gave the mechanism. I gave a little bit of reference to it in here, but I went really pretty much what Darwin was talking about with this topic here. So, why is this deer mouse well adapted to the forest? Well, you may not even have seen the mouse. You probably didn't even see it. All right, it was so well camouflaged. All right. However, this guy over here, this dark coloring is probably an advantage for survival. However, if he was living in white sands, oh, they wouldn't be so lucky. So therefore, the ones that live in the nearby sand hills are a sand-like color. Now, if we were all together, we'd be doing hands-on activities for natural selection. Probably would have gone on for 2 weeks. Please believe me on that. So anyway, natural selection is something we're just going to have to figure out how it works in a week. Fortunately for us, did find that simulation, which is good for adaptations, but it's not really good for the genetics and the alleles. And unfortunately, that's where we're just going to have to pass on that. Remember fitness, so we're dealing with, Thomas Malthus, right? The survival of the fittest, okay, is really what this is all about, But remember, fitness in Darwin's mind was how fit you are to adapt to a habitat, right? And remember plate tectonics and what Lyell was saying is that things change, that climates change, and that geography changes, that this weathering that we see on Earth today has been going on for millions of years, and now we know billions of years. Lyell didn't know that. And now we know how long it's been going on because of radiometric dating. Right? So evolution occurs by natural selection. That's what that's what separated Darwin from Lamarck, right? Lamarck thought it was that evolution can be passed on by an individual, all right? That individuals pass on natural selection. Instead, it's worked on by a population over a long period of time, all right? So this guy can't just will himself to be green, to try to avoid, to avoid, not that he'd want to be green. Obviously, he'd prefer to probably be, start off with a certain phenotype is a phenotype of physical characteristics which is advantageous for survival. In this case, these birds over here like to eat green bugs. All right? So therefore, being orange is an advantage, survival advantage. And as generations go by, this little orange bug, maybe they get together, and some of the offspring are, depending upon if it's recessive or dominant alleles, which are control of that phenotype of color, and sometimes it's a little easier than harder to actually get that trait into the population over a period of time. But over several generations, perhaps, the green bug allele, which is so unfavorable, eventually goes away, making all the bugs in a certain area a certain color. Evolution occurs by natural selection. Organisms with traits that are better able to survive and therefore pass their genetics down to the next generation. Inherited traits. These traits must be inherited from parent to offspring. There has to be a variation in these inherited traits. You have to have different colored fur in this case over here for this trait to actually get passed down from parent to offspring. Some of these traits are going to give individuals an advantage. All right. And so traits that give advantages in an environment, we're going to call those adaptations. Means the species are well adapted to their environment, which means they have traits that are well adapted for that very thing. And the individuals with those traits have a better chance of surviving, reproducing, and having organisms that maybe would have those traits as well, right? That's what it has to be inherited in a population over time, And that's what evolution is. It can't be happening within its own. Like this brown rabbit just can't say, I think that I want to, change fur color to be more likely to survive in a certain environment. Remember, that really that's why that Bioman thing is nice. Just an example of that. Some adaptations are better suited in different environments. All right, so inherited traits are passed on from one generation to the next. All right, so you got your parents, and then they pass those traits down to their offspring. Okay, this is like a little genetics lesson. This is from sixth grade. You probably remember this fondly, all the stuff you had with genetics. I was looking back, I was going to give you guys a genetics lesson, but I thought, you probably know this stuff already, right? Let's hide this. I forgot I got to make that. Whoops! I'm going to make that thing a little bit bigger. It's kind of funny. All right. So competition for survival occurs. This is Malthusian economics at work in the biological world. Love this stuff, right? Competition for survival occurs when there's differences in fitness amongst members of a population. There has to be differences in fitness, and therefore those organisms compete for survival and they compete to reproduce. As a result, some of the individuals will pass those genes down to the next generation. That's what we call selection. Nature selected. Now, is there situations where humans select? Yeah, there are. I mean, we change nature. I mean, we change environments, and yeah, we do this ourselves. But that's not natural selection. That's artificial selection, and that'll be the topic of what we're going to be covering next week. Before you get your assessment, that's going to be on the theory of evolution by natural selection, and then therefore we get artificial selection, which is more proof. All right, so these are the alleles. Remember, alleles get passed down from parent to offspring. This is your genetics lesson. This slide over here is basically about the genetics. I'll cover up that bunny. And these are dominant alleles. That's a recessive allele. Usually you have the lowercase. It's probably not the best image I've ever seen. I think I'm going to get rid of that one. I'll find something better. All right. All right. So the theory, some of these images kind of sum it up, and a lot of our assignments can be about this very thing. It's about just the whole idea about evolution. What does it take? First of all, you have to have more species that are born that could possibly survive. That's the first thing. Okay. That's why, that overpopulation is the first step. You've got to have more organisms that are born that could possibly survive to maturity. First step, overproduction, overpopulation. Second step is variation. Not every single organism can be the same. They have to vary, and those variations have to be genetic variations, which means that they could get passed on from parent to offspring. And the variations we're probably seeing over here would be size and color. I think that the antlers refer to being the gender itself, right? Now, selection is the competition. That's the fight for survival. This is the Malthusian economics. This is the fitness, all right? The competition. The selection is after the competition. This one is kind of missing competition over here. It kind of combines the two. And over here is like basically nature selecting which individuals can pass on and reproduce those traits. And in time, species adapt. Means those are traits that have been acquired over organisms over a period of time in a population, all right? And therefore, they're able to survive and reproduce, and it becomes more common. So you end up getting more in this case. You end up with, as you see how the populations change, you think over time, now there's more. Clearly, the one that they're giving an example over here would be fur color. Now, the reason why it's fur color is because it's the easiest thing to draw pictures of, all right? And there's another example. It's very similar. All right. Reproduction. You got more moths. Okay. Moths lay many eggs, which develop into caterpillars than adults. In other words, they lay more eggs than you can't imagine. If these moths didn't get eaten by other stuff, the whole world would be nothing but moths. And I'm glad there's these predators that eat the moths. But some moths are going to be easier to be seen, right? Which ones stand out? Which one has a favorable trait, right? Which one? That's right. It's this one. Did you see it? You probably didn't see it. These ones are easy to see, and that's what the birds might feel like as well. All right. So we have some genetic variation. In this case, once again, color. All right. So you're more born, then there's some variation. Then we get the economics, right? We get the fight for survival, the struggle for existence, the survival of the fittest. And the predators are able to find the white moths more easily than brown ones, right? So they can find those ones and which one's more fit for their environment, right? This guy doesn't even get to see them. He doesn't even see them. The birds that did you? Oh, you didn't see that one either, did you? You got to look closely, kids. And then eventually you see nature selects. Okay, nature selects which one is best suited for the environment. That is an adaptation. So these moths are adapted for their environment, being on a dark thing, right? So we get more variation, more genetic variation. Population can be inherited. Once again, they're competing for survival. All right, in this case, they're picking. This is just their larva. All right, now they're over here. Their larvas can now competing for survival. So the larva color matters too. Which one's more suited for the environment? Right. Once again, probably the darker color. Now these birds, yum, they see this one. These guys are sneaking away. And then finally over here, eventually we end up having more brown moths in environment. Nature selects. Nature selects. Now, one thing that you don't have the capacity with your Chromebooks to open this FetLab. It's too bad. It's too bad. All right. But if you have a chance to do this, so check it out. It's a lot of fun. All right. It's about population of bunny rabbits. I'm not too sure why it's not loading up. I might have to create a new screencast for this very thing alone. Oh, there it is. That's why. All right. A little bunny rabbit. All right. Let's get a brown fur bunny. Mutation. Oh, little mutation coming. Right. And time goes on. And looking for the time for our next bunny rabbit to come hopping on the scene. And we got these different things I can actually get this thing out of the way. All right. Get some food for our bunny rabbit. And we'd like to get time to go a little bit faster. Well, I think I'm going to have to play around with this thing a little bit more before I do this. Oh, game is over. I'm on bunny rabbit. Oh, jeez, that's what happened. All right. It'd be nice to get this thing to go a little bit faster. All right. So we got what happens in time with these bunny rabbits. All right. Mutations coming. Let's get a long tail one as well. All right. I wonder if I can figure out a way to edit this thing down a little bit. It's so much fun, though. But I think you'd really like this thing. We got to get some food. These guys are going to starve to death. All right. And let's make this the Arctic. It probably has got a better chance. All the bunnies died. Play again. What am I doing wrong? All right, I'm going to just end this screencast right now.